Hello students, so today we will be studying about one-dimensional motion using graphs. You shall be finding this under the chapter number 2 of your book, which is about one-dimensional motion. In the first unit on that chapter, basically you will be studying all about rest and motion, inertia, about scalar and vector quantities, and the three equations of motion. In this second chapter, you will find that there are certain graphs. Some of them are the displacement time graphs, some are the velocity time graphs, and so on, and the consequences, the inferences which are drawn from that graph. So let us do one by one. So the first type of graph that you will see there is the displacement time graph. So what does displacement time graph basically means? It basically means that you will have these two axes. Say this is the x-axis and this is the y-axis. The y-axis will be for displacement and the x-axis will be for time, and there will be some curve which will help us know that how the displacement varies with time. And from there we can find out quantities like velocity and so on. So first of all, there will be certain special types of graphs that you will see in your book. One is where in the displacement time graph you will find that the graph is a straight line parallel to the x-axis or parallel to the time axis. So this basically means, like, if this is 0 and say this value is 25, so and the time is increasing and so on in seconds. So what happens is, what is the information we can get from this graph, that at the time 0 second the displacement was 25 meters. And as the time increased, the displacement remained constant at 25 meters, which means that the body is not moving any longer. So the first inference we can draw from this conclusion is, from this graph, is that the body is at rest. Secondly, since the body is at rest, we can write down that the velocity of the body is 0. The body is not moving. So these are two conclusions we can draw from this special graph. The second type of displacement time graph that you will find in your book is where the graph is a straight line. Passing through the origin. This point here is the origin, and the graph is a straight line passing through the origin, inclined at certain angle theta with the time axis. So in this displacement time graph, since the displacement is increasing uniformly with time, so suppose at 1 second the value of displacement was something like, say, 10 meters. At 2 seconds the value of displacement was 20 meters. At 3 seconds value of displacement was 30 meters, and so on. Say as the time increases, the displacement is increasing. So this kind of motion is basically a motion with a uniform velocity. The word uniform is a key word here. Uniform velocity means the body is moving with a uniform speed and in a fixed direction, because velocity is a vector quantity. And how do you find the velocity from this kind of graphs? For that, you need to consider any region. Say I consider these 2 points. Between these 2 points I consider this small triangle, where this portion is my change in displacement and this portion is my change in time. And what is velocity? Velocity is basically change in displacement with change in time. It is how much a body has displaced in a certain time. By knowing these values from the graphs, we can find out what is the velocity of the body. This is the case of uniform velocity. The third case is where the graph is not so straightforward. In this case, it is neither a straight line parallel to x-axis nor a straight line passing through origin. Say the graph is looking something like this. It's kind of a curve. So if the graph is kind of a curve, in these cases, what are the conclusions we can draw and how do we find the velocity? The first conclusion we can draw is that the body is moving with a non-uniform velocity. Why non-uniform? Because velocity from the displacement time graph is obtained by the slope of the graph. Now if you look in this graph, at this point the slope is something like this, at this point the slope is like this, at this point the slope is like this. So at every instant of time the slope changes, and because the slope of a displacement time graph itself is velocity, that means the velocity also changes. So this basically, this kind of nature or kind of graph means that the body is moving with a non-uniform velocity. And in that case, if you want to find out what is the velocity at any instant, say I want to find out what is the velocity at this point, I draw a tangent at that point and then I consider the end points of that tangent, and from there velocity is equal to change in displacement by change in time. This is a velocity for the body at this particular instant, say at the point C. At some other point it will be different. But in this graph, the velocity that we found out is constant throughout the motion because this is a simple straight line. So from displacement time graph, this is how we can understand that whether the body is in rest or motion, and if it is in motion, whether it's moving uniformly or non-uniformly. And if so, what is the magnitude of that velocity. That brings us to the next type of graph, which is the velocity time graph. So velocity time graph means in the x-axis time remains as it is, but in the y-axis we have something like velocity. Velocity is unit meter per second and time is in second. Now again we can have those two same type of graphs, one where the nature of the graph is that it is parallel to the x-axis, and the other case where it's traveling straight from the origin. Now when it's parallel to the x-axis, what does this mean? Whenever any graph is parallel to the x-axis, it means that whatever value it had at the instant t equal to 0, it has the same value throughout. So this kind of graph represents that the body is moving with the same velocity. So if the body had a velocity of 20 meter per second at 0 second, it is moving with that 20 meter per second only throughout. Even though time is increasing, the velocity is remaining constant. So this kind of motions are called motions with uniform velocity. Remember, in contrast, that in the displacement time graph, the case for uniform velocity was a straight line passing through origin. And when in the velocity time graph, the graph is a straight line passing through origin, that means in this kind of motion, as the time is increasing, the velocity is also increasing. So that means there is a change in velocity with change in time, which means that this kind of motions are accelerated. So whenever you find that in a graph, for a velocity time graph, there is a straight line passing through origin, that means it's a case of uniform acceleration. Uniform acceleration. And how do we find out this acceleration? Simply, just like in the previous case, we draw a triangle. This is my change in velocity, this is change in time, and from there we can find out what's the value of the acceleration. And what is the case of non-uniform acceleration? Well, if in the velocity time graph we see that the graph is like this, a kind of a curve. We don't know the exact nature of the curve, it can be anything. If it's like this, a kind of a curve, then we will say that at each point the slope of this graph is changing, different slopes at different points. That means different values of this acceleration at different points. So this means this kind of a graph or any kind of curve which is not a straight line like this too means that it is a case of non-uniform acceleration. An interesting thing for the velocity time graph is that from the area of the velocity time graph you can find out the displacement. So suppose if this is my velocity time graph and this is the nature of the graph, and I want to find out that what is the displacement. Displacement is basically this area. The area which is enclosed by the graph with the time axis. This area is equal to the displacement. And how do you find out the area? Well, in this case it's simply a triangle, so we can do half into base into height, where this is my base and this is my height. If in some other case, like if there is a graph where the axis is straight, like in this one, the area is this area. In that case the area will be equal to, this is a square, so it is length into breadth, or you can say side square. So from finding out the area of these various geometrical bodies, we can also find out what is the displacement from the velocity time graph, and by using this formula for the slope we can find out what is the acceleration of the displacement